Welcome back, everyone. Now, before we dive into the whole, prototype that we want to show you, taking all of our components and putting it in the box, getting it all set up to show you, I wanted to kind of walk you through another example, something that myself and a bunch of students built here at UCSD not too long ago. I think maybe about a little over a year ago. The system is very similar to the one that we're going to be showing you, except a lot bigger. Now, we wanted this system to provide power for a lot more things. It's going to be in a shipping container. It's going to be providing STEM education to kids. Then we want to learn about DC power. They want to learn about AC power. We want to power fans, possibly an air conditioner. We want to make sure that there's lighting for the whole area outside. So the system had to be built a lot bigger. Anyways, right here, we walked through the whole process that we went through earlier, the diagram, how many panels we needed, how many batteries we needed, what kind of charge controller, inverter, everything. And we kind of came up with this design to meet that. So as you can see, kind of match the numbers there. The inverter, you have it there, a little gray box. Our charge controller, the battery packs, which are on the bottom. And then we wanted to do DC as well. So we have a 12-volt regulator and a 5-volt regulator. Another view of that is going to be right there. Seeing as though it's a workstation, a kind of semi-mobile workstation, we wanted to provide a place to work on, right? So you have a drywall. It's kind of like a mock wall, right? Drywall, you have your little workbench, computer station, and then we wanted to have our AC wall sockets on the bottom and our DC wall sockets on the top. This is still, process, something that you all at home should work through as well, deciding on how you want to build your station. Another little example from the bottom, and then comes the ultimate goal, which was to place it inside of a shipping container with plenty of access for students or whoever would like to use this system. The panels would be either mounted on top, kept inside the shipping container for safe storage, and then pulled out when they need to be used, etc., etc. The rest is up to your imagination, right? So we actually did this. There's the shipping container. It's an 8x8 by 20 foot shipping container. And we'll go into a little bit of the building process. Now, again, you can skip this video if you like. I just wanted to kind of show you something that, we made. And hopefully it can spark some ideas in your head, because maybe you don't want a rolling mobile surveillance system capable of powering the Dragon Board 410C. Maybe you want something bigger. Maybe you want something for your house. Maybe you want something for your shed outside, something bigger. So this is a great idea. All right, so here we go. This is kind of us working on it. What I said, measure twice, cut once. We first decided to mount the solar panels. We had these huge Kyocera solar panels. I think they were capable of over 200 watts each. Top of the line now pushes, I think, 300 watts on these big solar panels. But I mean, again, go back 10 years ago, 20 years ago, these things were enormous, huge, heavy. We're very lucky to have solar panels like this now. So we mounted them. We decided to go with 4 solar panels, 2 per structure. Our system was designed to handle, I think, 100 solar panels or something like that. So it's still capable for plenty of expansion. Something to keep in mind also when you're designing your capstone project. Maybe you want to get a big charge controller, a big inverter, a bunch of batteries, but maybe you only want to use 2 solar panels right now. You have plenty of time to charge it, and you want plenty of time to use it as well. So leaving that open for expansion, you could carry this system around with you, use it for a long time, bring it home, hook it up to a bunch of solar panels so that it charges really fast, and then go out again, right? So there's again, a lot of variables. We built our battery bank. As you can see, we used 4 batteries, 4 12-volt batteries, which makes it 48 volts in series. We did put it in series. And we wanted the battery bank to be detachable, so that you could move the batteries by themselves, and you could move the system by itself and then put the batteries back or replace the batteries easily, also for ventilation purposes. So you can see it's starting to come together here. This was the mock wall. You saw the 3D image. This didn't take a lot of time. If you have yourself and a couple buddies, it'd be really cool to see what you can come up with. This is us kind of, drilling some cabling holes so that, everything can be kind of maintained a little organized. As you can see, Eric, I don't know if you remember him from course 2 and 3. There he is mounting up the router. We have our charge controller up there, the inverter, and things are starting to come together. here is kind of the final product, I guess you could say, from the back end. So from left to right, they're both the same pictures, just zoomed in. The left side, you have your inverter. Right in the middle is the charge controller. Kind of the top right next to the charge controller on the right, that's a router. Below it, we have a breaker. In case something happens, it cuts the current so that nothing blows up. And then we have the two DC parts, the 5-volt regulator and the 12-volt regulator. All right, so it's starting to come together. We bring it out to our shipping container, and we set up our solar panels, and it's good to go, right? So that's just an example for you, right? I wanted to show you something exciting, something that, you know, any one of you are capable of doing on your own. And just to let you know, this system in particular is very capable of doing almost anything that you could probably need for your house, except obviously we didn't completely gear it out. But the charge controller, the inverter, all of that very high-end stuff. I think all in all, this whole project costed us about $3,500. But as you can tell, it'll probably save a lot of money in the long run on energy bills or anything that you might be paying in that you know I'm saying there. But yeah. So what kind of stuff are you capable of, or capable of doing, at least on the surveillance end, with a system like this, or even a system that we're going to be building in the next module? What kind of stuff have you used, or what kind of stuff would you want to learn about or integrate into your system? So here we have some electrical components, sensors. Some you have seen, some you may have not. Now, how could we use these for our surveillance system? How could we use them for our solar system? Now, you know the stepper motor. We've made programs for it. We've done it on Python using Linux. An example, what could we use the stepper motor for? Well, stepper motor can be used to rotate the solar panels. Say you don't want your solar panels attached to your box. Say you want them detachable and you want to carry your box around and then come back and charge it at a charging station. Well, you could program the solar panels to rotate, you know, based on the time zone you're in or whatever, to follow the sun. Just an example, you know, I mean, you could think of anything else. You could also get a light sensor and have it follow the sun. And I know that there are a lot of really cool sensors coming out, and we hope to integrate these into a future course. We'll see. But I2C sensors that we will hopefully be looking at one point. Stepper motor, you have the IR sensors. You know, you can break the IR sensor. You could send signals from the IR transmitter receiver. You have the RF, the RF identification key fobs there. You know, I mean, get close with the RF signal. Have the I don't know, sensor, the stepper motor trigger and open your box. You know, the passive infrared sensor. There's obviously infinite possibilities, and these aren't even all the sensors. There's so many more. I mean, there's hundreds of sensors out there. So I just wanted to talk to you a little bit about that. We will be talking more about the sensors that we will be using for our project in part 2. But I would recommend you all keep an open mind, and before moving on to part 2, start thinking about what you want to use for your project. I know you will have your list after this. Be sure, we'll have the conclusion summary as always, but be sure you look at our list. Be sure you check to see if any of the components are available in your area, and then start thinking about how you want to make this capstone project your own, and how you want to integrate as many sensors and as much functionality as possible. So see you in the next video.